Okay, so we're back. I forgot one thing, the septum. So if you look inside of a heart, there's a very, very strong muscle, very thick muscle that separates the right half from the left half. And that's called the septum. And that's because the heart is a double pump. Remember I said that? And the right half does one job and the left half does the other job. They do not work together in any way other than they contract at the same times. So, I just wanted to make sure I went over that. If you look, here is the visceral pericardium that touches the heart, also known as the epicardium, and the parietal pericardium, which is the outside layer with the fluid in between. Lines the internal surface of the outer layer of the fibrous dense connective. Yeah, I don't forget that one. Just know that the visceral one is the one that touches the heart and is also called the epicardium, and the outside pericardium is the parietal pericardium with fluid in between. All right, now if we look at this, this heart, you can see this right here is the septum. It's a very thick part, and it goes in between the right and the left halves. Okay, now it's important that we understand how this pump works. Okay, first of all, you have an inferior and superior vena cava. And the inferior and the superior vena cava bring deoxygenated blood back to the right atrium from the body. The superior vena cava brings it back from above your heart, like your head, right? That area above your heart. And the inferior vena cava brings it back to your heart from the rest of the body that's below your heart. Okay. These are big, big vessels, okay, because they're carrying a lot of blood. The next thing you have is you have on the back side of the heart a coronary sinus. Now, the heart has its own vessels because it needs to have a lot of oxygen, right? It's a constantly working muscle, so it has to have a lot of oxygen and it needs to be replaced fast. It needs to have sugar and, all the stuff that it needs to pump. So it has its own system. So there is a coronary sinus, and it is in the backside of the heart, and it is located on the posterior wall of the heart, which is backside, and it receives blood from the coronary veins. So the superior and inferior vena cava dump right into the right atrium. The coronary vessels veins dump into the coronary sinus. Now, the pulmonary artery goes from the right ventricle to the lung to oxygenate blood. It is the only artery with deoxygenated blood. So remember, arteries take blood from the heart to somewhere else. They carry blood away from the heart. So it doesn't matter whether it's oxygenated or deoxygenated. If it's carrying blood away from the heart, it's considered an artery. So the pulmonary artery carries blood away from the heart to the lungs. So that blood is deoxygenated. It's the only artery with deoxygenated blood. It goes to the lung, and then the pulmonary vein carries it back to the left atrium. That is oxygenated blood. It is the only vein with oxygenated blood. But it's carrying blood to the heart, so it's considered a vein, even though it's oxygenated. And then you have the aorta, and the aorta takes blood from the left ventricle into the systemic circulation. So blood goes from the right atria to the right ventricle to the lungs through the pulmonary artery. From the lungs, it gathers oxygen, comes back to the heart through the pulmonary vein into the left atria, down to the left ventricle, and then the left ventricle pumps it through the aorta to the rest of the body. And it's just a big circle, just like that. Now we'll be practicing this. I have a big heart on the floor of our classroom. You guys are going to love walking through. Okay. Next, we're going to talk about the chambers and the valves, okay? Because every chamber and valve has its own job. Now, First, we have the heart is divided into two parts. Okay, it's four chambers, right? There's one half is the right, one half is the left. There's four chambers. There's two atrium, one on the right, one on the left. There's two ventricles, one on the right, one on the left. The right atrium, or atria, the atria is plural for atrium, like more than one. Okay. The left ventricle is significantly thicker than the right, because the left ventricle has to push that blood through the aorta to the rest of the body. So it has to be a big, strong squeeze. So it is significantly thicker. There's more muscle involved. Okay. It says upper chambers left and right are also called auricle. I've never heard them called auricle, and you don't need to know that. It's atria, okay? Left and right, atria, okay? The lower chambers are the ventricle. Now, the heart has four valves that keep blood flowing in one direction. They prevent backflow or regurgitation, okay? So, the valve that you have on the right between the right atria and the right ventricle is called the tricuspid valve. And that's because there's 3 points or cusps of attachment. These flaps are attached to the chordae tendineae, which are attached to papillary muscles of the endocardium. And what happens is when the right ventricle contracts, that tricuspid closes, and so it stops backflow into the right atria. So when the atria contract, it pushes the blood into the right ventricle through the tricuspid. But when the tricuspid contracts, it shuts that valve so that the blood will flow to the lungs. You can't have backflow, or you won't have enough blood going to the lungs. On the other side, there's a bicuspid valve. Okay, the bicuspid valve is also called the mitral valve. I like to think of it as the mitral valve only because I always confuse tricuspid with bicuspid. So I know that the right is tricuspid and the left is mitral valve. And they call it a mitral valve because it's in the shape of a pointy bishop's hat. So, like the tricuspid, when the left atria squeezes, the blood flows into the left ventricle through the mitral valve, and then when the left ventricle squeezes, those valves are shut. Okay, and they are also, so the valves in the heart are connected to chordae tendineae, which are connected to papillary muscles in the endocardium. Okay, and we'll look at that and you'll see it a little bit more clearly. In fact, if we go backwards, we can see them right here. Okay, these are the chordae tendineae attached to the valves, and they are attached to papillary muscles in the endocardium. Now, you also have valves between the right ventricle and the pulmonary artery. That's the pulmonary semilunar valve, and between the left ventricle and the aorta, and that's called the aortic semilunar valve. So you have valves between the atrium and the ventricles, and valves between the ventricles and the vessels. The reason they call them semilunar valves is they kind of look like a half moon. Okay. The semilunar valve is what opens when the right ventricle squeezes to the lungs. That's the pulmonary semilunar valve. And then they close so that the blood doesn't go back into the ventricle. And it's the same thing on the other side. The aortic semilunar valve opens, pushes the blood through, and when the ventricle relaxes, it closes so the blood doesn't go back through. Okay, I think we're going to stop there, and we'll be back with the structure of the physiology, the circulation of the heart. Okay.